Right, this question has factorials on one side and then a cubic on the other. So this is a good one to practice to make sure you're okay with factorials. And interestingly, it's the definition of a factorial doesn't seem to be in the logbook. I couldn't find it anyway. But so it's vital to know the definition of a factorial. And the factorial, so the factorial of any number is you start with that number and you just multiply out decreasing numbers until you get to 1. So factorial of 4 is the number, put down the number, and then multiply it by the lower integer, by the lower integer, by the lower integer. So that's equal to 4 by 3 by 2, which is 48. So factorial n then is, okay, so you put the number and then it's the lower number integer, which is n minus 1, by n minus 2, and all the way down. You don't know what n is, but you know that it will end, all that multiplication chain will end at 1, right? So what will n plus 1 be? And all these kind of things, just apply the same rule. So it's n plus 1 by n minus 1 all the way to the 1, okay? N plus 3, then they're all the same principle. So n plus 3 is just write down the first number and then it'll be multiplied by the next lower number. It goes down by 1, so it's n plus 2 by n plus 1 by n all the way down to 1. So as you can imagine, with all of these things, they start with probably different numbers, but as you can see, there's going to be a lot of cancellation up here. And you have to be just aware of that in all of these questions, that if you get something complex, there's going to be cancellation. So be always watching out for that. Like as you can see there, you've n plus 3 up above, but that's gonna reduce to n plus 3 by n plus 2 by n and so on down. And it's basically going to cancel. A part of that stream of multiplication is going to cancel with this. And you'll just be left with n plus 3 by n plus 2, because the rest of it will be the same as this and it'll cancel. But you don't leap steps, don't jump steps, so go through each step at a time. So what's up here? Well, let's just call that is n plus 3. So we're going to take this and we're going to be very clear about where it's coming from, and we're going to say this, so the examiner knows that it's this is equal to n plus 2 by n plus 1. And then it's that factorial, because instead of just writing all of the n plus 1, we're going to just stop there, because that will cover all of the rest down, because that's n plus 1 by n, blah, 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 all the way down. All right? And this one, similarly, it's multiplied by n plus 2 factorial. And that is, you could write it all out, but because we have this underneath, we can just stop here at n plus 1 factorial. And the reason for that, let's just be clear about that. Why is the reason for that? Well, n plus 3 factorial is equal to, okay, n plus 3 by n plus 2 by n plus 1 by n minus 1, and so on, right? All the way down to 1. This bit here, that should be a 2. This bit here is basically n plus 1 factorial. And you can recognize that because the n plus 1 factorial starts with that number, n plus 1, and goes down and down and down. So that's why n plus 3 reduces to n plus 3 factorial reduces to n plus 3 by n plus 2 by, and all the rest is just n plus 1 factorial here. Similarly, with n plus 2 factorial, we see what's going on underneath, and we know there's going to be a nice juicy cancellation. So keep your eye on n plus 1. So it's n plus 2 by n plus 1 by all that, but all of that is going to be just n plus 1 factorial, right? Now, and underneath we have n plus 1 factorial multiplied by n plus 1 factorial. Okay, so now and always with these questions, just be aware, don't be running to the end too much and don't be too exhaustive. Always be aware of possible cancellations and never jump the gun, but just put it out like this. So that's not jumping any step. I mean, you could write them all out and do the, well, not all out, but you could just do what I've done there and just go down a few steps and go to 1 and then put a brackets around it and say you recognize that as n plus 1 factorial. Okay, so we've now basically reduced the large factorials in terms of the lower factorials by multiplying by some bigger numbers. So n plus 3, n plus 2, the bigger ones, and then until it gets to factorial n plus 1. And that's kind of the common factor here, if you like. Okay, so as you can see now, we're going to get lovely cancellation because n plus 1 factorial is now common above and below. Now you just have to be careful about how you cancel it. Now there's products in both here, so if we can now divide by n plus 1 factorial, okay, and we'll see how we get on there, and then we can divide by another n plus 1 factorial. So we're going to divide basically by the bottom and see what we get. Okay, so because, okay, so we get n plus 3 by n plus 2. That is, so we're going to cancel that one with that one. And then let's do a separate cancellation of that with that. So multiplied by n plus 2 over 1. Okay, so it has, yeah, so that's what we're left with. And that is equal to, and we're looking at the cubic here. And as you can see, there's going to be a cubic because we're multiplying 3 factorials, so that's looking nice. And just keep your eye on the answer. When you're given an answer, always just keep your eye on that because you know you're on the right track if it's kind of going that way. So let's multiply this bit out first. And we get n squared plus 5n plus 6, all multiplied by n plus 2. And that's equal to n cubed plus 5n squared plus 6n. So multiplying by that one guy first, plus now multiplying the 2n squared plus 10n plus 12. And then clearing that up, n cubed plus 7n squared plus 16n plus 12. Okay, so an cubed, and this is just a nice way of aligning them underneath, cn plus d. So we now have this lovely conclusion here. So a is 1, b is 7, c is 16, and d is 12. Okay, so really the aim here in all these factorials, okay, so it's important to know what a factorial is first. So you take the number and then you multiply it by all the lower numbers until you get to 1. So in these ones, what you're looking for is you want to cancel, and the cancellation is look out for the lowest factorials, and in those they're going to be, this is the lowest number factorial because it's only n plus 1. All the other ones are bigger, n plus 2 and n plus 3. So that's great first of all. And then just break down the larger factorials in terms of n plus 1 factorial and some numbers multiplied before them. That will lead to lovely cancellation, and then you will get your 3 factors which multiplied together give you the cubic. Hope that is the right answer first of all, but it's the right method anyway, so hopefully that makes sense.